Every single time you click your mouse, type on your keyboard, or watch a video, there's this silent, invisible hero inside your computer that's making it all happen. And no, it's not the part that's just crunching the numbers or the memory holding the data. It's something else. So today, we're going to pull back the curtain on the computer's true secret conductor. I mean, just think about that for a second. What part of your computer is actually in charge of everything? It's not the screen you're looking at, it's not the keyboard, it's something way, way deeper. So let's go on a mission to find this secret conductor that's leading the whole digital orchestra. All right, so to find our conductor, we've got to look at the computer's brain, the central processing unit, the CPU. But here's the thing, like our brains, the CPU isn't just one big blob. Nope, it's made of these really specialized parts that have to work together in perfect harmony.
And this, right here, just perfectly breaks it down. On one side, you've got the arithmetic logic unit, or the ALU. These are the musicians in our orchestra. They are the ones doing all the heavy lifting, all the math, all the logical decisions. But on the other side, well, there's our star for today, the control unit. And that is the conductor. It's the one telling the musicians what to play, when to play it, and how fast to go.
So let's zoom in and put the spotlight right on our conductor. This is the component that takes what could be total chaos, literally billions of digital signals flying around, and turns it into a perfectly synchronized performance.
Okay, so here's the textbook definition for you. The control unit, or CU, is the component of the CPU that directs the operation of the processor by generating timing and control signals. Basically, it is the source of all the commands.
But really, all that means is its job is to direct the entire show. The control unit doesn't do any of the math itself, but it makes absolutely sure that everyone else does their job at the exact right nanosecond. So what does a conductor like this actually do during a performance? I mean, what are its main jobs? Let's dig into the control unit's core responsibilities, moment to moment. The control unit is locked in this constant, ridiculously high-speed loop. First up, it fetches an instruction. That's like our conductor reading the next bar of music. Step 2, it interprets that instruction. It has to understand what it just read. Is this a math problem? Does it need to grab some data? And finally, step 3, it generates the signals. This is it, cueing the musicians, telling the right parts of the computer to get to work and execute the command. Fetch, interpret, execute. Over and over and over again, billions of times a second. So you can see, the most important thing to get here is that it's a master coordinator. It carries out the instructions from your programs by talking to the computer's memory, think of that as the orchestra's gigantic music library, to get the data it needs. Then it passes all of that to the arithmetic logic unit, our musicians, so they can play their part. And all the while, it's making sure every other component, from your graphics card to your internet connection, is perfectly in sync. Now, you can't be a conductor without your tools, right? You need your score, your baton, the whole setup. Well, the control unit is exactly the same. It has its own toolkit, a set of special, super-fast memory locations called registers. And what's so cool is how perfectly these tools fit our orchestra analogy. Let's break them down. First up, you've got the program counter, or PC. This is like the full musical score. It always knows exactly which instruction is coming up next. Then there's the instruction register, or IR. This holds the instruction that's happening right now. It's the specific note the conductor is staring at this very moment. Finally, the MAR and the MDR are like a little team that goes and fetches the data. The memory address register, the MAR, is like a library card. It holds the address for where to find the data. Then the memory data register, or MDR, is the temporary spot that holds the actual sheet music, the data itself, while it's being carried from the library to the stage. So when you put all of these pieces together, you've got the core loop, the constant coordination, these special tools, you really start to see the full picture. And all of this happens completely invisibly at speeds we can barely imagine, which really makes the control unit the ultimate unsung hero of computing. We always get excited about our fast processors and our amazing graphics cards. They get all the applause. But this quote, it just nails it. Without the control unit directing the flow of everything, all that powerful hardware would just be a chaotic mess of electrical signals. It would just be noise. So, just how fast is this performance? Well, in a modern CPU, our conductor coordinates over 3 billion operations every single second. That's 3 billion times it has to fetch, interpret, and cue the orchestra. The scale of that is it's almost impossible to wrap your head around.
So the next time you fire up a game or just open a new tab in your browser, take a second to remember that silent conductor working at the heart of it all. Its flawless, high-speed direction of this incredible symphony of billions of operations is what makes our digital world feel so smooth, so instant. It really makes you wonder, what other incredible complexity is hiding right there, in plain sight, just waiting for us to understand it?